Today, we're diving into a mind so profoundly different from ours, it's like meeting an intelligent alien. We're going deep into the world and the mind of the octopus.
So just try to picture this. An animal with not one, not two, but 3 hearts. Its blood is blue because it runs on copper, not iron, and its body is so incredibly fluid it can pour itself through an opening the size of its own eyeball. This isn't science fiction. This is a real animal.
The philosopher Peter Godfrey Smith really hit the nail on the head. He said the octopus is probably the closest we'll ever come to meeting an intelligent alien. And that's because right here, on our own planet, it represents a completely separate, totally independent experiment in how to build a complex mind.
To really get our heads around this alien intelligence, we first have to understand just how different their bodies are. Their entire blueprint for how to be an animal is just fundamentally different from ours.
This right here flips our whole body plan on its head. For us vertebrates, it's simple, right? Head, then body, then limbs. But for an octopus, the order is body, then head, then limbs. This means their mouth is literally located where their armpits would be. It's a completely different way to assemble a creature.
So this brings up a massive biological puzzle. If you've got a body with no bones, no joints, and basically infinite ways to move, how on earth do you control that thing?
The word for this is protean. It just means they are masters of shapeshifting. But that variability creates this huge computational problem for the brain. And the way they solved it? Well, that's where things get really, really weird. Okay, so let's just do a quick rundown of some of this bizarre hardware they're working with. First up, 3 hearts. Yeah, 3. 2 of them are just for pumping blood through the gills, and the third one circulates it to the rest of the body.
And that blood? It's blue. That's because it uses a copper molecule called hemocyanin to carry oxygen, not iron-based hemoglobin like us. It actually works better in cold, low-oxygen water.
Now get this, their central brain isn't a solid ball like ours. Nope, it's shaped like a torus, basically a donut. A pretty strange design for your main processor, you'd think. And here's where it just gets mind-bendingly weird. Their esophagus, the tube that carries food to the stomach, passes directly through the hole in the middle of that donut-shaped brain. So, with a body of pure possibility and this bizarre anatomy, how does this creature actually think and operate?
Well, the solution to controlling that protean body is radical. Instead of having a top-down CEO in the headquarters kind of brain like we do, the octopus evolved something totally different. A distributed, decentralized network of intelligence.
The numbers really tell the story. An octopus has about 500 million neurons, which, is in the same ballpark as a dog. But here's the kicker. Nearly 2/3 of those neurons aren't in the central brain. They're located out in the arms.
And to put that into perspective, every single sucker on an octopus arm has up to 10,000 neurons just for taste and touch. An octopus doesn't just feel the world with its arms, it tastes and it smells the world with them, pulling in a massive amount of data with every single movement. What this really means is that each arm acts like its own semi-independent little brain. It has its own local sensors and controllers. In fact, if an arm is completely severed, it can still perform complex movements like reaching and grasping for hours. The arms can even pass information to each other without ever needing to check in with the central brain. It's wild.
So the big question is why? Why did they evolve this way? The answer goes way, way back in evolutionary history, to a path that split from our own hundreds of millions of years ago.
It turns out evolution built complex minds twice on 2 completely separate paths. Go back about 600 million years, and our last common ancestor was some kind of simple little worm. From there, the path forked. One branch led to vertebrates like us, concentrating all the neurons into one big central brain. The other branch led to cephalopods, which took the opposite approach and distributed their nervous system all over the body.
So what kicked this whole thing off? It seems to be the loss of their ancestral shell. That created this intense evolutionary pressure. All of a sudden, they were soft and vulnerable, but at the same time, they were incredibly flexible. And this started a feedback loop, a kind of body-brain arms race. A more complex body needed a bigger nervous system to control it, which then allowed for even more complex senses and behaviors, and so on.
And this all brings us back to the biggest, most mind-bending questions of all. If an intelligence is built so differently, what is the internal, subjective experience of an octopus actually like? What does it feel like to be one?
Think about it.
For us, our sense of I feels like it's right here in our head. But if 2/3 of your mind is in your arms and each arm can kind of do its own thing, where is the I? Is there even a single unified self in there, or is it something else entirely?
Godfrey Smith puts the puzzle so well. He wonders if there's a sense of self at all. The central brain might not be a conductor leading an orchestra, but more like one musician in a jazz band, improvising with its arms. It's a collaborative, distributed consciousness, a concept so foreign, it just pushes the absolute limits of our own imagination.
So in the end, we're left with this fundamental question. We can study their neurons, we can watch what they do, but we might never be able to truly cross that huge evolutionary gap to understand what it feels like to be a mind that is both one and many. A mind that tastes the world with its skin. What is it like to be an octopus? It's a question that really forces us to rethink what a mind can even be.